Okay, let's dive right into this explainer. For a lot of people stepping into the design world for the very first time, there's this massive psychological roadblock. We tend to mix up design with art, right? And that leads to this huge myth that if you want to create a functional digital interface or a killer graphic, you need some sort of innate, mystical, artistic genius. And hey, if you don't feel like you have that raw talent, you probably feel like you just can't play the game. Well, today, we are going to completely shatter that myth. We're reframing design. It's not about aesthetic self-expression. It is a rigorous, completely learnable process of behavioral engineering. Design actually runs on established rules, measurable objectives, and cognitive psychology. By the time we wrap up here, you're going to see that it's really just a set of logical tools meant to deliberately guide human behavior.
To get us there, we've got a pretty clear roadmap. First, we'll tackle the blank canvas myth. Then, we'll explore design as invisible engineering, dig into affordances versus signifiers, look at why it's function over decoration, and finally, wrap up with controlling visual hierarchy.
So, starting off with Section 1, the blank canvas myth. We really need to talk about that profound intimidation beginners face when they stare down a brand new, completely empty project space.
Seriously, if you've ever felt totally paralyzed right at the start of a project, you're in incredibly good company. Even Vincent van Gogh felt it. He actually said that the blank canvas seems to stare back at the creator, mesmerizing them into a state of idiocy, whispering that nothing can be done. I mean, wow. Why is it so daunting? Well, because it represents the total unknown. When you think of design as pure, boundless self-expression, the possibilities are literally infinite. And let's be real, infinity is utterly terrifying.
That paralysis actually has a name. It stems from a specific cognitive overload called decidophobia. Basically, it's the paralyzing fear of making a wrong choice that leads to blurred thinking, overanalyzing everything, and desperately needing someone else to validate your work. Think about it like having way too many options, kind of like a small fish in a massive school trying to confuse a predator. You just can't focus on any single direction. Should the background be blue? Do we make the text massive? When there are no parameters, there are literally no correct answers. So how do we fix it? Well, it's not by chasing absolute freedom. The cure is adopting strategic constraints. The second you define a project by its objective, its target demographic, and its functional goals, boom, the canvas isn't blank anymore. It has defined edges. You aren't creating in spite of these limitations, you are creating because of them. Moving right along to Section 2. Design as invisible engineering. Because once we let go of that whole infinite artistic freedom idea, we can finally embrace what design actually is, a highly calibrated vehicle for directing human behavior.
I mean, we've all been there, right? You walk up to a slick glass door in some modern office building, you reach out and you confidently push, only to smack directly into the glass because guess what? You were supposed to pull. Why does that happen? It's a hugely relatable frustration, but it illustrates a really critical point. Good design removes friction. Good design is almost entirely invisible. Think about it, you rarely stop to admire the elegant typography on a checkout screen when it just works perfectly. But bad design? Oh man, bad design becomes acutely, frustratingly obvious.
And that brings us to an absolute cornerstone of user experience, the Norman door phenomenon. Named after cognitive scientist Don Norman, it refers to any door whose design makes it confusing or super difficult to use without trial and error because it's giving you incorrect communication signals. Look, if a door has a flat metal plate, but you actually have to pull it to open it, it's failed. The physical shape of the door is screaming at you to push, providing a totally incorrect signal. The core issue here isn't your intelligence or your observational skills. When you forcefully push a pull door, the door failed you.
Which leads us to something so important, the eradication of user self-blame. Usually, when a product is hard to figure out, we internalize it. We think, I'm so dumb, I should have known to pull that. But a massive tenet of modern design education is that human error is usually a system error. Systems have to be engineered with the expectation that humans are going to mess up continually. It beautifully shifts our entire mindset away from just creating pretty things over to engineering real usability.
All right, on to Section 3, Affordances versus Signifiers. Let's build up the vocabulary we need to actually diagnose why a design fails, like that annoying Norman door.
The very first concept we need is an affordance. Basically, this dictates what is functionally possible. It's the relationship between the properties of an object and the capabilities of the person using it. So, a chair affords sitting. A physical button affords pressing. Now, here's the crucial part. An affordance exists whether anyone actually realizes it or not. A hidden door built seamlessly into a bookshelf, that still affords passage to another room, even if you're standing right in front of it and have absolutely no idea it's there. Affordances simply establish the realm of physical possibility.
But as we know, just being possible isn't enough, and that's where signifiers step in. While affordances dictate what you can do, a signifier is any perceptible signal, visual, auditory, tactile, that communicates where and how you should do it. A printed label reading push is a literal explicit signifier. But think about digital interfaces. A flat phone screen doesn't naturally afford clicking, right? It's just a piece of flat glass. So designers have to rely entirely on visual signifiers like drop shadows, contrasting colors, or hover states to create the illusion that something can be pressed down. Bottom line, if a feature has an affordance but completely lacks a signifier, your users are never going to find it.
And this brilliantly illustrates exactly how designers systematically help users bridge what cognitive psychologists call the gulfs of execution and evaluation. Look at the flow here. When a user forms a plan, they're relying on affordances just to know an option even exists. Then, to actually perform the action, they need signifiers and constraints to guide their hands. After they take action, the perceive stage, they need to observe the system's reaction, which requires immediate feedback. Finally, they interpret and compare to see if they actually achieved their goal. By mechanically walking users through these exact cognitive stages, designers completely eliminate the guesswork.
Okay, Section 4, Function over Decoration. Now we're going to look at how all these principles actually show up in the real world by comparing two extreme ends of the design spectrum.
Let's contrast a totally chaotic promotional flyer for a local underground band, the kind stapled to a telephone pole, with a standard highway exit sign. That band flyer? It's usually designed with the purest blank canvas mentality. We're talking crazy distorted typography, clashing colors, logistics scattered everywhere. Viscerally, sure, it might succeed at evoking this emotional, rebellious vibe, but behaviorally, it completely fails to tell you when and where the actual show is. Now, in stark contrast, the designer of a highway sign does not have a blank canvas. They are entirely boxed in by extreme physical and environmental constraints.
And let me tell you just how precise that highway sign engineering really gets. For decades, older drivers were dealing with this dangerous optical effect at night called halation. Basically, bright headlights would reflect off the sign and create this glowing halo that completely washed out uppercase text, making it impossible to read. To fix this, researchers literally engineered a new font called Clearview. And they didn't do it to make the sign look prettier, they did it to save lives. They figured out that mixed-case words drastically improved legibility. And get this, they mathematically engineered the lowercase loop height to be exactly 84% of the uppercase letter. They purposely opened up the negative space inside the letters to stop that glowing effect from filling them in. That is undeniable proof that cognitive engineering trumps pure decoration, hands down, every single time.
Which brings us to our final stop, Section 5, Controlling Visual Hierarchy. Because how do you actually take all this and exert control over a blank canvas to guide the human eye systematically?
Well, establishing that hierarchy means you first have to understand how humans natively consume information. And extensive eye-tracking research tells us something very clearly. Digital users skim and scan. They do not read line by line. On a text-heavy page, our eyes naturally move in an F pattern. We scan horizontally across the top, move down the left side, and shoot across again when a keyword catches our eye. For more visual designs, we use a Z pattern, across the top, diagonally down to the left, and then horizontally across the bottom. These aren't just preferences. These are innate, biological reading patterns.
But here's the magic. Designers can deliberately override those biological tendencies by manipulating what we call visual weight. These are your mechanical levers. You can use size and scale, knowing the squeaky wheel gets the grease, right? Bigger things get red first. You can play with color and temperature, where bright, warm colors literally appear to advance toward the viewer, while cool colors recede into the background. You can use the sheer physical width and boldness of typography to demand attention, or my personal favorite, you can use white space. Just surrounding a tiny element with a vast expanse of empty space instantly elevates its prominence. These are structural tools, not just artistic flair.
Now, what's really interesting about this slide is that it gives you a highly practical 6-step toolkit you can use to audit any layout right now. Step 1, define your single message. Step 2, ruthlessly rank every element into levels 1, 2, and 3. Seriously, if it doesn't support the main message, get rid of it. Step 3, choose your layout skeleton, like that F or Z pattern we talked about. Step 4, apply your typography rules. Step 5, use color decisively, like reserving your one main accent color strictly for the main interactive button. And finally, Step 6, run the 3-second test. An impartial observer should be able to glance at your design for exactly 3 seconds and tell you the primary takeaway. It just completely removes all the guesswork.
When you start treating design as functional, behavioral problem-solving, that paralyzing anxiety of the blank canvas, it just completely dissipates. You aren't guessing at art anymore, you are calculating human-centered communication. Whether you're analyzing a frustrating pull door or marveling at the life-saving constraints of a highway exit sign, you now have this lens of invisible engineering. So, I'll leave you with this final provocative thought. Now that you understand visual hierarchy, affordances, and signifiers, are you ever going to be able to look at a simple door or a highway sign the exact same way again? Probably not. So go start applying these specific constraints, take control of your user's attention, and bridge that gap between intention and action. Thanks so much for joining me on this explainer, and happy engineering.